when we use graphs, they have meanings. There's not just for the purpose of sitting in math class and filling things out. So graphs are always used to illustrate a lot of different situations. Doctors use them when they're looking at someone's heartbeat, so on an EKG. Businesses use them to show trends in sales and production, right? You've seen this is supposed to be like a graph on a display table. Scientists use them to demonstrate data, and my math students know them to pass the EOCT. So every graph can tell a story, all right? You just have to know how to read it. So you're going to get this worksheet in class, but if we take a look at this graph, it's got all kinds of different lines. Some are straight and flat, some are going up, some are coming down, some are all bumpy. So let's take a look at each one, what these mean. So if it goes up pretty quickly, all right, it's increased sharply, dramatically, quickly, or rapidly. So you can say this increased dramatically, this increased quickly, this increased rapidly. All right, you went from 0 to 100 in less than 6 seconds. This is going up really, really fast. All right. This one is going down, but at a very, just barely going down as you move to the right. So this one's decreasing slowly. It's decreasing gradually. All right. This is extremely bumpy as it's going up, but it is increasing. So it rose or increased variably. It increased at an uneven pace. This one goes exactly straight across. It's not going up. It's not going down. It's stayed the same. It's remaining constant. Okay. This increased steadily, all right? Increased gradually, increased slowly. This starts way up high and gets way down very, very quickly. This decreased sharply, dramatically, decreased rapidly. And then this one, again, went back to bumpy. So this is dropped variably or at an uneven pace. You can say decreased at an uneven pace. So if we think about this, if this were a graph of somebody's grades, okay, if this were a graph of somebody's grades, then this would be they increased really fast and they decreased a little bit and then they rose really uneven, they stayed the same. Now grades typically don't decrease this badly, but it's because you can't go all the way down to 0, but it's just an example. This could be somebody's grades. This could be, there's all kinds of different things this could be. This could be something that started off frozen and got cooked and got refrozen. Okay, lots of different things to think about. All right, so if you take a look at a graph like this and it says give 2 phrases that could describe, so you could say it increased gradually, or there was a steady increase, okay? Or sketch a graph that shows the speed of a car decreased dramatically and then remained constant. So they're traveling along real fast and they see a cop, so they slam on the brakes and then they just stay at the speed limit the whole time after that. Just as an example of what the story could be. All right, so then it gives another thing you might be asked to do is if you're given a couple different descriptions and a couple different graphs and it wants you to connect them. So a baby lost a little weight and then gained weight slowly. So if we take a look at these graphs, which one goes down first and then goes up, and neither one of them really fast? Well, that's this one. It decreased a little bit and increased a little bit. The baby gained weight at a rapid pace. Well, comparing these two, this one looks kind of slow and this one's going up a lot faster. So this would be increased at a rapid pace. The baby gained weight at an uneven pace. Whenever you see that word, you're looking for something bumpy. So there's our bumpy part of the graph right there. And then remained at a constant weight. So that's just an example of what you might be asked to do when it comes to comparing a story to a graph. So when a graph is created by a line, it's called continuous. When it's created by a bunch of dots, that is called discrete. So the difference between the two is continuous graphs are used when the data is connected at every point on the x and on the y-axis. So if you're talking about the increasing sales or just monitoring sales over time, well, you could be making sales constantly. A height increase with age. You don't, well, even with the growth spurt, you still got to actually connect the dots. I mean, you don't go from 4 foot to 4'5" with no time passing in between it. So that's going to be continuous. Discrete graphs are used when the information is not necessarily connected. The number of items sold per day. So if your x-axis had days on it, 1 day, 2 day, 3 days, and you're only selling stuff on the day, so if you're judging the number of items sold per day, then you're putting a different dot that aren't connected. Or your attendance per year to an event. Okay, so if you have a concert every year in June, then you're going to have the different years along the bottom and you're going to put the attendance as you go up. So that's not going to necessarily be connected. So you're going to be asked to read a situation and sketch a graph, and you'll be asked to read a graph and make up a situation. So some examples is create a graph that models the following. Mark is draining a tank and has to open a valve to let it drain. He started by opening the valve just a little. After a while, he opened the valve as far as it would go. Then he closed the valve when all the water was gone. So if you start with a fish tank that has a water level that's high because it's full, when he opened the valve just a little bit, it's had a slow and steady decrease. Then he opened the valve all the way, and it drained really, really fast until all that water was gone. So make sure that if you're asked to make up a graph that you label which one is your water level and which one's time. So this was the level of his water, and this is time passing as he's opening that valve. So create a story to go with the following graph. So if we have a graph like this, and I wrote the possibilities are endless, this graph could represent all kinds of stuff. It could represent temperature of food when it's being cooked. It could represent the pace that somebody was running. It could represent how fast a car was going, how fast an airplane was going. It wouldn't necessarily represent somebody's height, though, for example, because somebody doesn't get taller and then get way shorter. It wouldn't necessarily represent somebody's age. So there are different things that it can represent, lots of different things that it can represent, some things that it wouldn't make any sense to represent. So my example for this one is going to be, as I look at this graph, it increased slowly, stayed really, really steady, and then decreased consistently. So I would say that I pulled something out of the oven and it wasn't hot enough, so I stuck it in the microwave, and as I pulled it out, it stayed hot. I put it on a warmer and it stayed hot for a certain amount of time, and then as I pulled it off the warmer, it cooled really, really slowly. So there's an example.